Hello, here on Pablo Spot. I'm George. Welcome to a new episode on this series on different ways of managing AWS credentials used when standing up infrastructure from code. Apologies for the groggy voice. I feel so much better, but I still have not fully recovered from the dreadful COVID yet, but I just feel the itch to do a brain dump today. And so in today's episode, I will be writing infrastructure code with Terraform to reflect the different AWS Single Sign-on components that I've set up manually in the previous episode. And so if this series and the content of this channel lines up with your interest, hit the subscribe button and join me in this journey of learning by doing. So, let's start coding. I will create a new Git repository for today's changes. So the first thing I would do is create the directory, and then cd to this new directory, and then initialize Git. I am also going to run my script to create the template Terraform scripts on this directory. And then I'm going to launch VS Code to start the actual work. The first thing I will do is update my backend.tf. When I set up AWS SSO manually in the last episode, one of the key components that I configured is the permission sets. This is what I'm going to set up first. So inside my main.tf, this resource needs an instance ARN property that points to the AWS SSO instance on my account. The value of this property will be derived from a data reference, so let me head to my data.tf and define this. So back to my main.tf. I will then set a property for this resource called instance ARN and point this to the first element of the data reference that I just defined. One thing to note here is that the ARN's property is a set property, so I need to convert this to a list to be able to get a reference to an index. The next set of properties that I need to define are the name and the description properties for this permission set. In the previous episode, I set two permission sets, one for administrator access and another for view-only access. I can actually go ahead and duplicate this resource block in here, but this is going to be difficult to maintain. What I will do instead is set up this resource to use the for each block to create each of the permission sets in one resource definition. I will set the source of the for each property to a variable. I need to head to my variables.tf to set this definition. This variable will be a list of objects with specific set of properties that will include the name and a description of the permission set. I also have a property for my permission set called session duration, so I might as well add that property in this object. I will not set any default value for the variable to make this a required input to my Terraform module. So now back to my main.tf. I have declared my permissions list variable as a list. So instead of referencing the variable directly, I will need to make a transformation of the variable and translate the list into a map of objects. I have redefined my list of permissions into a map using the name property as the key. I can then update the source of the name and description properties to the elements of the map. Like I mentioned earlier, this resource also needs a property called session duration that defines the length of time a session is valid. So I will also source the value of this property from the variable elements like this. And now that I have permission sets, I need to attach the actual permissions to these permission sets. The first set of permissions will be through the manage policy attachment resources. So let's create that resource block. Instead of explicitly coding individual policy attachments, I will use the same block for all policy attachments that I need to set. These will all line up with the permission sets later on. So what I will do is head to my variables.tf. I will update my existing permission list variables and add a new property to hold the managed policies I would like to assign to each permission set. And in order for me to derive a list of policy attachments to create, I need to interpolate the managed policies inside the variable. And to do that, I'll head to my locals.tf and define a local parameter called manage policies that will hold a list of objects that contain both the permission set name and the actual policy. To set the value of this local parameter, I will loop through each element of my permissions list variables, and then loop through each element of the manage policies property and create a map that contains both the name of the permission set and the actual policy ARN. This logic creates an embedded list on my local parameter. So what I need to do is ensure that I end up with only one flat list. So I'm going to wrap the entire logic with a flatten function. And now that I have this transit local parameter defined, I will define a new local parameter that will hold a map of policy ARNs that I need to attach to each appropriate permission set. What I will do here is look through each element of the local managed policies list and define a new map of objects with unique keys set as a concatenated string of both the permission set name and the policy ARN. And now if I head back to my main.tf, and in the for each property, I will look through each element of the local managed policy ARNs map to set the managed policy attachments. This policy attachment resource requires properties, so I'll start with setting up the instance ARN property, which needs to point to my SSO admin resource. So far, I've used references to instance ARN twice. I'm going to make my life easier by defining a local parameter that points to this data reference. And so let me copy this line here, and then head to my locals.tf, define a new local parameter and call it SSO instance ARN, and plug that in. And so now back to my main.tf, I can then replace all references of this line to my local parameter. The next two properties that I need to set are the values that I've set inside my local parameter. The manage policy ARN property is pretty straightforward. All I have to do is pull out the value. The permission set ARN will need to point to the permission set resource that I've set up previously. And the way to reference this is by using the permission set name like this. The next thing that I need to do is assign the permission set to the appropriate AWS Single Sign-on group and AWS account. So I'll head to my variables.tf to start the work. I will add two new properties on my permissions list variable. And then I'm going to head to my locals.tf. I need to derive a list of AWS accounts and single sign-on group combinations that I will use to set the account assignments. I will loop through each element of the permissions list. And then I will derive a new map that contains the permission set name and AWS account and group. What I've done here is fetch a Cartesian product between the AWS accounts list and the single sign-on groups list, and then create an object that contains the permission set name, an AWS account, and a SSO group. The next thing I will do is create another local parameter that will interpolate the contents of the account groups list and create a map with unique keys using a concatenated string with the permission set name, AWS account, and the group name. I also need a list of unique group names, so I'll create a new local parameter for this. And to avoid duplicate group names in the list, I will wrap this with a distinct function. The next thing to do is to fetch the identity store groups linked to the AWS groups. So let me head to my data.tf. I will define the data reference to the identity store group resource. I will create this data reference for each single sign-on group, and so I will add a for each property that will loop through each element of my local groups parameter. This data reference needs a identity store ID property, and this will come from the single sign-on instance on my AWS account. Earlier, I defined a local variable that holds the single sign-on instance ARN, so let me head to my locals.tf. I also need to define a local parameter that points to the identity store ID on the same single sign-on admin instance. Let me head back to my data.tf and update this property. I will also need to add a filter block to extract the appropriate single sign-on groups. And now I can create the account assignment resource. So back to my main.tf. I will create this resource for each of account group assignments set inside my local parameter. This resource will require an instance ARN property, and I will also need permission set ARN. I will reference a permission set resource. I will use the name as the key reference to pull the appropriate resource, and it will look like this. This resource will also need principal ID, which will point to the data reference to an appropriate identity store group. I will use the group name as the key reference to pull the appropriate data reference. The next property that I need to set on this resource is the target ID, which I will point to the AWS account ID. And the last set of properties I need to set are the principal type and target type. Next up, I'll create a Terraform configuration file in the root of this repository to stand up my infrastructure. So let me head to my VS Code Explorer. Inside this Terraform configuration file will be my Terraform block, and then my inputs block. In the previous episode, I set up 2 permission sets, so I just need to set up the bare minimum components for now. And now, let me switch to my VS Code terminal and set my default workspace and my AWS credentials. I also need to export my workspace prefix and then run my script to create my Terraform workspace. And now, I'm gonna run validate on my script. I got 2 validation errors, so let's go ahead and fix that and add the missing Y. The other error is on line 17, and I think it's complaining about this. Now let me head back to my VS Code terminal and rerun my validation. And that looks good. Remember that I have set these resources manually in the previous episode. So what I will do is extract the current resources and reflect them inside my Terraform code. So what I will run is Terraform import to do this. Or in this case, I'm going to try to run Terraform import. But first, let me run Terraform plan to... My Terraform plan was successful, and it's telling me that 2 resources are going to be added, which are the permission sets. To import the permission set, I need the associated ARN of the existing resource, as well as the SSO admin instance ARN, which we know from the output of the Terraform plan. To pull this data out, I need to switch to my browser and log into my AWS web console. I need to head to my AWS Single Sign-on dashboard, navigate to the permission set section of the page, and then I need to take note of these ARN values in here. So let me switch back to my VS Code terminal and start importing my permission set resources. And now, if I want to see the list of resources on my Terraform backend state, I can just issue this command. And if I want to see the contents and properties of this particular resource, I can issue this command. The next thing that I want to do is this time importing my view-only access permission set into my Terraform code. Now that both my administrator access and view-only access permission sets are imported into my code, I'm going to rerun Terraform plan. And this time, the result of my Terraform plan shows that 2 resources are going to be changed. Now, let me head back to my Terraform configuration file. So let's head to my VS Code. So for the AWS accounts, I will add 2 accounts in the list that I've set in my previous episode. And for the groups, I will use the 2 groups that I've set up in the previous episode. And for the manage policies, I will update the list based on which policies I assign to each permission set. And now I'm all set to rerun Terraform plan. So let me head back to my VS Code terminal. The Terraform plan was successful, and it's telling me that there will be 6 new resources that will be created, but I will not create this. Like what I've done so far, I will import what has already been created and reflect that inside my Terraform code. And now that all my resources are imported, let me rerun Terraform plan. And now, instead of 6 new resources to be created, I'm down with 2 resources to be updated. And if I run Terraform show list, my current Terraform state has all these resources in it. This exercise is to show how finicky the process of importing infrastructure resources can be. The complexity lies on the amount of parameters that you need to piece together to be able to import an existing resource. The Terraform registry documentation will provide you with all these parameters, so this is not something that you need to memorize or know by heart. DevOps mindset will always tell you to get your infrastructure into code, and so I suspect at some point you will have resources that have been set up by hand that you need to extract into a code so you can version control and share the knowledge through code. That's all I have for today. Next time, I will look into AWS Vault to see how this tool can be used to manage AWS credentials used to spin up infrastructure using code. In the meantime, let me know what you think in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning, stay safe, and stay healthy. Now it's time to disinfect.